Alright, before we graph tangent and cotangent, we're going to do an example of secant. So why don't you find this, draw the sketch and find the domain and range of this function here. Two things you want to do right away. What's one thing you want to do?
Switch it to cosine.
Very good. Switch it to cosine. And excellent. Factor out a half. Those are the two things to start with. So far, so good. Got the cosine. We've got amplitude, period, locator are up by. Means my locator is negative 2 pi negative 2 right here. Alright, so it is a positive cosine, so we're going to start one amplitude above our locator point. Our amplitude's 3, so 1, 2, 3. There's my first point right there. Then down to the midline. How many got that far? Okay, good. I may not have given you enough time. So now, if we're graphing secant, you have to draw your vertical asymptotes every time you hit a sine locator. Every time the curve hits the midline is an asymptote. And then you just bring the graph down. You go back up, make sure it hits that point, make sure it gets close and close to asymptote on both sides. Alright, questions on that? So most of the work is just graphing the cosine. For you, without different colors, you probably did a dashed line there. You could use different colors. I'd recommend you use different colors. Okay, so now see if you can figure out the domain and range of the secant graph. Let's figure out the domain and range of that secant graph. Alright, so for the domain, we have to find the, well, first of all, the domain's all reals. X not equal to. We have to find the first vertical asymptote at or after the y-axis. What is it? It's pi. So not equal to pi plus. Then we have to figure out how often your asymptotes occur. What is it? 2 pi. Here, 2 pi is there. Every 2 pi the asymptotes occur. So it's all real numbers. X not equal to pi plus 2 pi n. Just to confirm, give me a small number. 3. Well, I don't have 3. Well, 3 might not be. So if I plug n in for 3 in for n, I get 6 pi plus pi is 7 pi. So if I had a extension of this graph, 7 pi would be another asymptote. If I picked 1, n is 1, so I get 3 pi. It can't be, so x can't be anything where n is an integer. It'll always give you the asymptotes. So that covers every single asymptote. Infinite amount of asymptotes. And the range, it goes all the way up until it gets to -5. So the range is from -infinity to -5, including -5. And then it starts off at 1 again and goes up, so 1 to infinity. Raise your hand if you got the domain and range correct. Alright, only a couple of us, so that's somewhere we can grow a little bit. Okay, so now tangent. If I was just going to graph y equals the tangent of x, I'll give you the parent graph of it. So yeah, for those in person, it's sitting there right on the board. So tangent x, the general form is what you would expect it to be, a times the tangent of b times x minus h plus k. There are a couple differences, so we're going to do tangent and cotangent today. I think by the end of the hour, I'm going to ask you, or I'll see if I can remember to ask you. Some would argue that tangent and cotangent are easier than secant and cosecant. I think that's what most people would say, but there are some subtle differences that you can't forget. Tangent, the a for tangent, a positive a will look like this, and a negative a will look like this, and I'll show you what tangent actually looks like. So if I went, this is pi over 2, this is negative pi over 2, this is what tangent x looks like. And there's an asymptote, a vertical asymptote at negative pi over 2 and pi over 2. Okay, so positive a, it's going to go up, negative a, it's going to go like that. The period is actually pi over b, not 2 pi over b. If you look at just the graph of tangent x, how long is its period?
I don't know.
Pi. Yeah, it goes from here to here, from negative pi over 2 to pi over 2, that is pi. We could keep going. Well, actually, I'll say my up pi is actually the period divided by 2 instead of period divided by 4. So there's a couple differences. The period is 2, it's not 2 pi over b, it's pi over b, and the up pi is the period over 2, not over 4. So if my period here is pi, I'm going up by pi over 2. My next point would be pi, and then 3 pi over 2. There's another asymptote, and there's another period of y equals tangent x. Keeps on going forever.
So it's like a repeating, like
Yeah, they're called periodic functions. They just continue to repeat the periods. Everything we're working with in this 5.6, actually sine, cosine, all those are periodic functions. Yep, 2 periods would be 2 of them. Yep. All right, so let's try one together. Let's try y equals 3 times the tangent 2 times x plus pi. By together, I mean you'll probably need my help more than anything here.
yeah.
So get as far as you can with it. Yeah, good question. So the amplitude, I didn't talk about that. So the amplitude, if it's positive, it goes up. If it was 3, it would look like this. If it was 5, it would look like I'm concerned. If it was 10, it doesn't matter. As long as it's positive, it's just going to go up. Now, it'd be a little skinnier, but for our purposes, any positive will look like this. Notice half of the period for tangent is on the right side and half of it is on the left side. The locator is right in the middle. Half of it's to the right, half of it's to the left. If it was -5, it would just go down. If it was -3, it would go down. It doesn't. I don't care about the shape of it as long as it goes down through that point. So this has an amplitude of 3, so it's going to look similar to the shape of this at least. All right, so our period is pi over 2, right? Locator, negative pi is 0, and what's my up by? Good, pi over 2 divided by 2, so pi over 2 divided by 2 is the same as pi over 2 times 1/2, which is pi over 4. Okay, so we're going up by pi over 4. Our locator is negative pi 0, so most of our graph is going to be on the left side of the y-axis, negative pi 0. So and we're going up by pi over 4, or 1/4 pi. So that's negative 3 pi over 4, negative pi over 2, negative pi over 4. I'll keep going. So that's pi over 4, pi over 2, 3 pi over 4. That's plenty. All right, so your x-axis should be labeled in increments of pi over 4. My locator is negative pi 0, so I actually need one more on the other side. So remember, if this is my locator right here, half of the curve is going to be on the right, half is going to go on the left. So your asymptotes are going to look like this. And then it's a positive amplitude, so it's going to go up like that.
So the amplitude doesn't really mean so much other than whether it's positive or negative.
That's exactly right. Yeah, so the magnitude of the amplitude, like how big it is, I don't care. Okay? Questions on how I graphed it? What's the toughest part of this graph? For you, what was difficult? Or was it all super simple? We'll see in the next, the next one I'll let you try by yourself and see it. Okay, let's do the domain and range of this one. So see if you can figure out the domain and range of this tangent. All right, anybody want to try domain? Domain, okay, it starts with all real numbers, x not equal to. So we have to find our first vertical asymptote at or beyond the y-axis, that is pi over 4 I'm hearing. So not equal to pi over 4 plus, how often do the asymptotes occur? Every pi over 2, very good. It's actually going to be the period every time. So pi over 2. How many had that? All right, the same people that had the domain and range last time. The range, all real numbers. All right, just because I like you so much, I'm going to throw everything I got at you into one problem, the first problem you ever graphed for tangent. So see how far you can get on this one. Make a sketch of it. Eventually, I'll ask you the domain and range also if you want to go on to do that. Give it a shot. All right, so we've got an amplitude of 4 negative. Period is pi over b. B is 1/2, so pi divided by 1/2 is clearly 2 pi. The locator is pi comma 3, and my up by is the period divided by 2, so we're going up by pi. My locator is pi comma 3. I'd better do a little bit of this. So pi comma 3 is my locator right there. Remember, half of the curve is on the left, half is on the right. So the up by should take care of, like, you don't have to think how far to go to the right and left if you did the up by correctly. So it's a negative tangent, so it's going to look like this. And my next one will be right here. There's another asymptote. And look like that. And we could do this all day if we wanted to. Sounds like fun to me. All right, raise your hand if you got something close to that. Nice. See if you can figure out the domain and range. The third time I'm asking today. I'm hoping for more than 3 hands.
Okay, let's see.
All right, so domain would be our first asymptotes, right? Well, it's all real numbers. x not equal to 0 plus 2 pi n. How many got that right? Way better, very good. The range would be all real numbers. Okay, so that is tangent, graphing tangent. We are now going on to cotangent. For the last few minutes, we'll do probably just y equals the cotangent x. General form is what you would think it would be. That's a whole lot of letters, a whole lot of blurry letters. Just like tangent, the period is pi over b, not 2 pi over b. The locator is still h comma k. It's kind of our theme all year long. And our up by is the period divided by 2. All right, so cotangent, what does it look like? This is what y equals cotangent x looks like. That is positive cotangent x. Okay, this is the locator right there on the y-axis. So a couple different things. A positive cotangent, what's it look a lot like? Negative tangent, right? So don't mess up the positive and negative for cotangent. If it's positive, it goes down. Okay. Also, this is the locator point, and the curve does not go through the locator point. It actually has a vertical asymptote going through it. Okay. But other than that, the period is pi over b. The up by is the period divided by 2. A lot of things the same. Okay, this is my locator, and the entire period is to the right of it. Where tangent, half is to the left and half is to the right. All right, so let's see if we can graph 3 cotangent of x plus pi minus 1. See how far you get with that one. All right, so amplitude is 3, the period is pi over b, b is just 1, so the period's pi. The locator is negative pi comma negative 1. The up by is the period divided by 2, so pi over 2. Our locator is negative pi negative 1. I'm going to put a dot there. There's my locator. We know that there is a vertical asymptote that goes through the locator. And then we go to increments on the x-axis, and we're drawing our asymptotes. Alright, so if it's negative pi negative 1 is the locator, and it's a positive cotangent, it's going to go through, what's the one point that it's going to go through? Negative pi over 2 comma negative 1. Very good. It's going to go through this point right there. It's going to go through pi over 2 negative 1 and 3 pi over 2 if we wanted to do 3 periods. Alright, see if you can figure out the domain and range on this. Alright, who wants to try the domain? Anybody want to try it? What do you got? Say it in a low frequency so I can hear it.
All real numbers.
All real numbers. X not equal to?
Not equal 0, right?
Yep.
Plus pi.
Plus pi n. Very good. Yep. You want to try range also?
All real numbers.
All real numbers. All right, good job. Questions on this stuff? Why is Peter Pan always flying? He never lands.